Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to consider a problem of finding the area of a region that lies between the graphs of two functions. And first, we are going to consider the first scenario where the area of a region is bounded by the curves y is equal to fx and y is equal to gx. So we have these two functions here, fx and gx, where fx is always greater than or equal to gx for all x in the interval of a and b. So you can see based on this figure here, this is the graph of fx, and you can see that it is greater than the graph of this one, so the curve here, this is gx. And therefore, if you apply this formula given here, you will be able to find the area between the two curves. Okay, so let me just explain to you more about the idea of this formula given here. So if you see this formula, this can be separated when you want to evaluate the integral, the difference of fx minus gx. That can also be obtained by considering the integrals separately. You can have fx dx minus the integral of gx dx. Now, what is the meaning of this integral here? So this one is all about finding the area under the curve of fx. So this is fx, so this is fx, so the area under the curve is from this point and go on until it reaches this point here. So this is the area under the curve, and you can represent the result as according to as a. Okay, you can represent the result as a, and then for the second part here, this is the integral for gx. So this is about finding the curve, the area under the curve of this one. Okay, so this is another area, and I hope that you will see if you have a minus b, so you have a minus b, then you will get the area between these two curves. So that's the graphic representation of the formula given here. Okay, now we're going to just apply this formula, and we will apply this based on the question given here. You can see that this is asking you to find the area of the region bounded by this guy. So this is y is equal to x squared plus 1, so that is the upper boundary. Okay, so that is bounded above by y is equal to x squared plus 1, and below by y is equal to x. Next, it is bounded on the sides by x equals to 0 and x equals to 1. Okay, so first of all, let us just sketch the area of the region here. So if you sketch the area, it will be looking more or less like this. This is x-axis and y-axis. So we know that if you have y equals to x squared plus 1, the graph is going to be looking like this. And this is and this point is 1. We are just, so this one is 1. Okay, next, when you have the boundary here, x is equal to 0, so this is point 0, so this is x 0, and then we can have x equals to 1, so this could be x equals to 1, so this is x equals to 1. So so next, you will have another line here is y is equal to x, so it could be like this, could be looking like this, y is equal to x. Okay, so now I'm just going to label all this function here. So this is y x squared plus 1, and this is y is equal to x. So the region bounded by all these curves are this one. So these are the region that you are looking for. Okay, so you can see clearly that for this one, this is always greater than, so for this region from 0 until 1, from 0 until 1, this is always greater than this one. Okay, so this is greater than this one, so in order to find the area, we can apply this formula here. So this one is going to be your fx, and this one is going to be your gx. Okay, so area is just you integrate from 0 until 1, so 0 until 1. So fx is this one, because this is the nature of it is greater than or equal to gx, so this is your fx, x squared plus 1, so minus gx, so gx is this one, so gx is equal to x. Okay, so this graph is gx. Okay, next what we can do is we have x squared plus 1 minus x dx, and you get the antiderivative of it. It's going to be x cubed over 3 plus x minus x squared over 2 evaluated at 0.1 and 0. So this becomes 1 over 3 plus 1 minus 1 over 2 minus 0. So next we can find the common denominator to this, so this is going to be equal to 6. 6 divided by 3 is 2, plus this one is 6 minus 3, and this is equal to 8 minus 3, which is 5 over 6. Okay, so that's the answer to this example 6.7. Well, thank you very much for watching, and I'll see you in the next video.